Alright, in this clip we're going to look at the first 40 marks on the WJEC Summer 2018 Intermediate Maths paper. So the first 40 marks takes us up to and including question 9. You get that far and you're well into the grade C and into grade B category. Okay, using only the numbers in the following list, write down two prime numbers that have a sum of 32. Well, first of all, we need to identify the prime numbers. So we knock out the evens, and then we knock out multiples of 5. So it leaves us 11, 13, 17 and 19, which are the prime numbers. So I'm looking for two of those that will add to give me 32. So 19 and 13, just check. So 9, 12, 32. So the two numbers are 13 and 19. A number that is a multiple of both 4 and 6. So multiples mean that they live in the 4 times table and also in the 6 times table. 6 goes up 6 and 12. I know that 12 is in the 4 times table, so the number is 12. And then factors of 51 are numbers that divide exactly into 51. So if we list them as pairs, we have 1 and 51 that aren't in the list. 2 doesn't go into 51 because it's an odd number. So then I'll try 3. So if I do 3 into 51, 3 goes into 5 once, remainder 2. 3 goes into 21 7 times. So the factor is 17. So those are those values. Question 2, circle the correct answer for each of the following. So these are metric to imperial conversions that you're expected to know the rough values. You're expected to know that 5 miles is about 8 kilometers. So 5, it's not giving you much space here. So 16 kilometers, well, that's twice 8. So I'd have to double that to give me 10 miles. So I'm looking for 10. 2.2 pounds is approximately equal to 1 kilogram. Again, that's one that you're expected to know. And 4 litres, well, half a litre is about a pint. If you think a pint glass is about half a litre. So that means 1 litre is about 2 pints. So if 1 litre is about 2 pints, 4 litres will be about 8 pints. So that's what they're looking for there. Question 2. The table shows some values of y equals x minus 3, values of x from -4 to 6. Complete the table above. Well, what I often suggest to students to do is, first of all, plot the points that you're given, because then you'll have an idea about what the missing points are. So -4, -7 is there. I don't know that one. 0 is -3. 2, I don't know. 4, I don't know. And I know that 6 is 3. And I also know that this is a straight line. So my points have to lie on a straight line. And I can see there that that is lying on a straight line. So -2 is -5. I can just pull those off now. 2 is -1 and 4 is +1. because I knew that that was going to be a straight line. To do it the sort of normal way, answering question A before going to part B, what you would do is your equation is y equals x minus 3. So when x is minus 2, y will be minus 2. You're replacing the x with minus 2, taking away, oops, I've written down the answer, minus 3, which is negative 2, going down another 3, negative 5. When x is 2, y will be 2 take 3, which is negative 1. X is 4, y will be 4 take 3, which is 1. So either way you do it, you should get those points. Part C. The straight line you have drawn on the graph for values of x from negative 4 to 6 is the diagonal of a square. Write down the coordinates of the four corners of this square. Well, if going from there to there is the diagonal, that pretty much tells you that the square is there. So the coordinates they want you to write down are these on those 4 points. So if we start down here, this one is minus 4, minus 7. This one is across 6 down 7. Up to here, 6, 5. Sorry, 6, 3. And this one, negative 4, 3. Quite an unusual question, but hopefully you would have managed to pick your way through that. Question 4. A bag contains a number of different coloured balls. A ball is selected at random from the bag. The probability of selecting a blue ball is 0.3. Explain why the following statement is incorrect. More than half the balls in the bag are blue. Well, you know that if all the balls in the bag were blue, then the chances of you pulling one out is 1, because it would be certain. For there to be more than half, the probability would have to be more than 0.5. So we need to put that into words. So what I'm going to say is if more than half the balls were blue, then the probability of selecting a blue ball would be greater than 0.5. It isn't. It is 0.3. So in your words, that's the sort of thing you'd want to be saying. If more than half balls are blue, then the probability of selecting a blue ball would be bigger, greater than 0.5. And it's not, it's 0.3. What's the probability that the ball selected at random from the bag is not blue? Well, total probability is 1. So if we take that 0.3 from 1, then the chances of it not being blue is 0.7. There are 50 balls in the bag. How many of them are blue? So 0.3, lots of 50. 5 3s are 15. And then you've got, so 0.3 of 50 is 15, or 3/10 of 50 is 15. So 15 is what you're looking for there. Okay, this is another unusual question, doesn't come up very often. Draw an isometric representation of a cuboid measuring 6 centimeters by 4 centimeters by 3 centimeters. So it's going to look something like six, 4, 3. You could have it in a different orientation, but that's what we need to draw. And when we draw an isometric shape, the gaps between the diagonal dots represent a centimeter. So if I start it down here, so if that's 1, 2, 3, 4, 5, 6, that would be all right. 1, 2, 3, 4, 5, 6. So that's 6 centimeters. Then I'm going to go 4 centimeters in this direction. 1, 2, 3, 4. And then I'm going to do a 3 centimeter height. 1, 2, 3. So then I just draw in the extra 1, 2, 3. Then I need 4 along there. 1, 2, 3, 4. So there you go. So that's 6 by 4 by 3. As I said, you could have had it standing upright or in any of the other orientations, and that would be fine. So the volume of the cuboid is length times width times height. So I've got 6 times 3 times 4. 3 4s are 12, 12 6s are 72. Now this is the question that's instructing you to give you units. So 72 is correct, but it won't earn full marks. The units of volume with centimeters would be centimeters cubed, because you're doing centimeters times itself 3 times. So you get the unit mark for putting that in. Question 6. The table below shows the first 5 terms of a sequence of numbers. Circle the correct equation that connects the term T6 and T7. So if we see here, what is happening is that it's going up in 3s. So T7 will be whatever term 6 is plus 3. So term 7 will be the previous one, term 6, plus 3. So it's a bit of a confusing way of writing that, but again, it's one of those ones that hopefully you can work that out, even though probably as maths teachers we don't use that format very often. The nth term of another sequence is given by 2n take 11. So the 10th term will be when n is 10. So that would be 2 lots of 10 take away 11, which is 20 take away 11, which is 9. The third term, n will be 3, which is 6 take away 11, which is, so you're at 6, you're going down 11 spaces, you'll end up at negative 5. Question 8. Find the whole number that satisfies all of the following conditions. It's a whole number between 1 and 100 inclusive. Inclusive means it could be 100 and it could be 1. 10% of the number is greater than 2 but less than 8. Half of the number is a square number and the number is not a multiple of 4. Right, so we could start by writing a list of numbers between 1 and 100. which isn't great. This clue here is probably the most powerful, because we know how to find 10% of a number. The whole numbers, and when you find 10%, you divide by 10. So the number is greater than 2, so the first whole number would be 3. If 10% is 3, then the whole number is 30, because 10% of 30 is 3. So it's either going to be 30, or 40, or 50, or 60, or 70, but it can't be 80 because it's less than 8, and similarly it can't be 20 because it's greater than 2. So 10% of that is 3, 10% of that is 4, 5, 6 and 7. It's one of those numbers. Half of the number is a square number. Well, a square number is one that when you multiply a number by itself, it produces the square number. So if we half that, we get 15. 15 isn't a square number. If we half 40, we get 20. 20 isn't a square number. If we half 50, we get 25. Now 25 is a square number because 5 5s are 25. Half of 60 is 30, not a square number, and 35 isn't a square number either. So that is our square number, which means that the only number between 1 and 100 that fits all these clues is 50. So let's just check. 50 is between 1 and 100. 10% of the number is 5, which is between 2 and 8. Half of it is 25, which is a square number, and 50 is not in the 4 times table. Job done. Question 8. So this is our OCW question, so we need to be methodical about how we go about setting out the maths. It's not a question where they want you to write a story about how you do it. You just need to make sure you're consistent with your units and you explain each line of maths as clearly as you can. So in the diagram below, ABCE is a square whose perimeter is 28. CDE is a right angle triangle whose area is 35 centimeters squared. Calculate the length of DE. So this is DE. Okay, so if I know the perimeter is 28 and it's a square, so the 4 sides are of equal length, then I can work out the length of the side of the square. By doing 28 divided by 4, which is 7 centimeters. So I've explained what I'm doing, I've done it, and the answer has got the correct units, that is 7 centimeters square. So that then means that I know that that is 7, that is 7, that is 7, and that is 7. And I also know the area of that triangle is 35. So area of triangle, and they've called it CDE, will be a half times the base, which is 7, times the height, which we don't know. So I'll just keep that in there as DE, or you could call it question mark or X or whatever you want. But I know that that area equals 35. So I've got an equation now which I need to solve. I get rid of the half first of all by multiplying everything by 2. So if I'm timesing by 2, if I times that side by 2, I have to do the same to that side. So that leaves me 7 lots of DE on that side equals 70 on that side. Now to get the DE on its own, I have to divide by 7. If I divide that side by 7, because it's an equation, I have to divide that side by 7 too. So DE, 7 divided by 7, dealt with, is 70 divided by 7, which is 10 centimetres. And that's it. No stories, just consistent explanation of what I'm doing and consistent use of units. Question 9. Reflect the shape S in the line y equals 1. So the most common mistake people make here is that they would put y equals 1 as that line there, reflecting the shape across that way. This line, it's the x coordinate that's 1. So that's the wrong line. We want the line where the y coordinate is 1, which is this one. So that is the line y equals 1. And when you reflect, the distance, the perpendicular distance, the right angle distance that each corner of that shape is from the mirror is reflected in the opposite direction. So if this is to that side, it's going to end up there, and it's going to end up there, and then from there we can see how the shape is going to unfold. And often I will say when doing this sort of question, if you turn your page around so that your eye line is running along the mirror, your brain more easily recognizing the symmetry of it when you're looking along the mirror. So as I've turned that now, I can see, yep, if I fold that over along the mirror, it will overlap perfectly where that is. So you need to be careful where the mirror line is. Describe fully the single transformation that transforms shape S onto shape T. Now the clue here is it's 3 marks. So if you just wrote it's a rotation, you're only going to get, if any, 1 mark for that. You have to be more precise when it comes to a rotation. You need to say how much of a turn there has been, in which direction, and where the rotation was held about. So the way to do that is to get your tracing paper, trace the original, put a little up arrow, and I would start with the origin. I would start pinning it there because it does get quite difficult to find where the rotation happens if it's not the origin. So on an intermediate paper, I'd be thinking it's going to be about the origin, but let's have a look. Yeah, so I've turned that through 1/4 of a turn, so it's a 90-degree turn, and I've turned it in that direction, which is clockwise. It's the same way the hands of a clock turn. So it's a rotated 90 degrees clockwise, and you pinned it about the origin or about 0, 0. So that's what you need to do to get your 3 marks. Yes, it's a rotation, but how much of a rotation is it? 90 degrees clockwise, and where did you pin it down? The origin. So that takes us to the end of question 9. So those are the first 40 marks. So if you've got those in the bag, you C is safe, and you're now going hunting down in the second half of the paper for the grade B marks.